Welcome everyone. In this video we're going to do a 14.7 problem. I put this in the 14.7a category here. We're back in spring 2016. There it is. Spring 2016. We're doing problem number 2 here. So we have a nice function and it looks like we're interested in maximums and minimums and what's going on here. And so let's go ahead. Remember we need to, it looks like, find and classify critical points. So I'm going to go ahead and find them first, take some x derivatives, some y derivatives, figure out when are one of these undefined or when are they both equal to 0. So if I take the x derivative, it looks like I get 4x squared plus 6y. And if I take a derivative with respect to y, it looks like I get 6x plus 6y. And so remember, for critical points, I'm looking for where are one of these undefined. Well, in this case, right, there's no division, there's no square roots, there's nothing. So the only hope for critical points is when both of them are equal to 0. So let's go ahead. I like maybe this f sub y a little bit nicer here. I think we can get 0 is equal to 6x plus 6y. Let's go ahead and divide by 6. So we get x plus y is equal to 0. So I get y is equal to negative x. Now we can go ahead and take that and maybe use it up here. So let's go ahead and plug it in. Remember, we want this one equal 0 as well. So I get 4x squared minus, and again, so I have this minus here because y is equal to negative x. So this is going to be minus 6x. Okay, so if I go ahead and maybe factor this a little bit, I can factor out a 2 and an x, and then let's see, I'd have 2x minus 3 left over. So this is going to give me either x equals 0 or x is equal to 3/2, it looks like. Now remember, these are the x values. Let's go ahead and get the y values. I'm going to look right here, right, because again, I want x plus y to equal 0, so aka, right, y is equal to negative x. So in this case, we would have, if x is equal to 0, y should be negative 0. And if x is equal to 3/2, y should be negative 3/2. I actually forgot the negative sign there. Negative 3/2. So we have 2 points. We have 0, 0, and we have 3/2, negative 3/2. And that kind of makes sense, right? All of these, answers over here are talking about 2 critical points, right? 1 local minimum, 1 local maximum. 2 saddle points, 1 local minimum and 1 saddle point, right? All of them have 2 critical points. So the fact that we have 2 of these things, well, that's a good sign. Now let's go ahead and calculate out this d value, right? For that we need f sub xx, we need f sub yy, we need f sub xy. So I'm going to go back to my first partial derivatives and I'm going to take more derivatives, right? So okay, let's go ahead here. Maybe look at this f sub x for a second. So if I take another derivative with respect to x, I'm going to get 8x. If I take a derivative instead with respect to y, I would just get 6. All right, now let's go ahead and look at f sub y. If I was to take the derivative of with respect to y here, again, I would get out 6. So in this case, right, this d, this determinant of a Hessian matrix, right, we have to multiply f sub xx times f sub yy, so that's going to be 48x. And then we go ahead and we subtract away f sub xy squared, so that's going to be minus 36. So now let's go ahead and look at maybe at 0, 0, what would d equal? Well, d would equal negative 36, which is less than 0, so we have a saddle point. Okay, what about at 3/2, negative 3/2? 3/2, negative 3/2. All right, we would have d is equal to, all right, and again, I'm plugging in 3/2 for x, right? So I would get, let's see, 48 divided by 2 would be 24. Let's multiply that by 3, like 3 days. That's going to be 72. And then I go ahead and I subtract away 36. So that's going to be equal to positive 36. Well, that's greater than 0. So remember, we have to look at f sub xx. F sub xx is going to be 8 times our x value. 8 times 3/2. Well, the big thing here is that that is greater than 0. So remember, that means it's concave up, so we have a local min. Local min. So we have 1 saddle point and 1 local minimum. So therefore the answer is C. All right, that's how we do that. So again, this was this day 1 of 14.7. We were just talking about local mins, local maxes. In my next video, we'll do some absolute mins, absolute maxes. I'll see you then.